Welcome to an important session of digital signal processing. Here I will be discussing most important questions from module number 4, and you can expect these kind of questions in the university examination as well as gate examination. So let me discuss the first kind of numerical example. Finite impulse response low pass filter using rectangular window. So question will be in this fashion. Design an FIR LPF using rectangular window with the following parameters. The filter specifications are cutoff frequency omega c, that is given by pi by 2, where filter length m is given by 4. Some cases it is like different parameters. You no need to confuse. So these are the parameters they have given. So now what to do? We have to design FIR low pass filter using like a rectangular window. So let us brief up the numerical example with the following 5 steps. Step number 1, you have to calculate alpha. We have the standard formula alpha equal to m by 2, length by 2, that is equal to 2. Done. Second one is write ideal impulse response formula. This formula you are supposed to by heart it. Sin omega c into n minus alpha by pi into n minus alpha. Thereafter, substitute omega c and alpha here. So you are supposed to substitute. Later on, substitute n is equal to 2. Okay, you are supposed to substitute n equal to 2. Then you are able to get hd of 2, that is equal to omega c by pi. You already know that omega c equal to pi by 2, which is already given in the question. That is equal to 0.5. Then apply the rectangular window. Here omega n will be equal to 1, where n lies between 0 and 4. Ultimately, we will be getting h of n is equal to hd of n. That is the final answer. The exam preparation tip, rectangular window is equal to no modification. If such kind of like question is asked, you have to remember h of n will be equal to hd of n. So if final answer is hd of n, you are able to get the full marks for this question. So you can expect the question like this. Let me discuss another numerical example from module number 4, FIR LPF using handing window. So question is like this. Design FIR LPF using handing window. Conditions are given. Filter specifications are omega c equal to pi by 3, where m is equal to 6. There are 5 steps. Alpha value to be calculated. Like is alpha is equal to m by 2, right? That is 6 by 2, that is equal to 3. Ideal impulse response hd of n equal to sine pi by 3 minus n minus 3 upon pi into n minus 3. Substitute n is equal to 3, correct? N is equal to 3, you are supposed to substitute. Therefore, I will be getting 1 by 3. hd of 3 is equal to 1 by 3. Then apply the handing window. So remember the formula of handing window, which I discussed in the previous class or previous session. 0.5 minus 0.5 cos 2 pi m by 6. That is the standard formula. Substitute n value, you are supposed to substitute n equal to 3. Therefore, I'll be getting h of n is equal to hd of n into w of n. So make a small table and you try to remember this. So that is the hd of n into omega of n is the final answer. FIR high pass filter using window method. Here FIR SPF with omega c equal to pi by 4, m equal to 6. Step number 1, design LPF first. So using this formula, you have to calculate HLP of n. Then convert LPF into HPF. What you are supposed to do? Use this conversion. Delta of n minus 3 minus h of LP of n. So h of n is nothing but h of, small letter h of hp of n into w of n. W of n is the window factor, correct? The w of n. Okay. Now, golden formula you are supposed to remember. Sp of n is equal to, sorry, h of hp of n equal to delta of n minus alpha minus small letter h of lp of n. It is a standard formula. It's a golden rule, I should say. Numerical number 4, linear phase FIR filter type identification. H of n is given. Okay, impulse response is given. One impulse signal is given. 1, 2, 3, 2, 1. Then solution. It is symmetric when h of 0 is equal to h of 4, comma h of n, that is equal to h of 3. Length is equal to 5, that is odd. The answer will be type 1 linear FIR filter. These are the shortcut you should remember. Then numerical example 5, direct form realization of FIR filter. H of z is given 1 plus 0.5 z to the power minus 1, 0.25 z to the power minus 2. Write the difference equation. You convert you have to calculate the difference equation. You know Z inverse and Z transform. How to calculate the Z transform. Then you convert Z domain into normal, y of n. H of Z should be converted into y of n. Difference equation is given. H of Z is given, so difference equation. Direct form structure. 2 unit delay, you are supposed to maintain 3 multipliers and 1 adder. Equation plus block diagram, you are able to get the full marks. Then h of z equal to 1 plus z to the power minus 1 into 1 plus 0.5 z to the power minus 1. So first section is equal to y1 of n. y1 of n is nothing but x of n plus x of n minus 1. Cascade form realization problem. So it depends on the present input and the previous input, right? So y of n is equal to y1 of n plus 0.5 into y1 of n minus 1. So why cascade is required? Because it is less complex, better numerical stability. Apart from that, it is most frequently asked question. So these are the different type of questions you can expect from module number 4. Kindly go through these steps, that is most important. Accordingly, try to solve the numerical example. So you can discuss through comment window. Sorry, you can discuss through like a comment box. Any queries are there, you can directly put the query over there. I'll try to respond. So these are the important type of questions you can expect. Thank you so much for watching this video. If you need the similar kind of video, request you to subscribe our channel. Also, kindly like this video if you found it is helpful for others. Also, request you to share the video those who are preparing for the subject digital signal processing, especially for VTU, KTU, and the different gate examination, etc. Don't forget to give the comments for the improvement. Happy learning. Have a great day. Thank you all.